Diesel engines are everywhere, quietly doing the heavy lifting of modern life. In the next few minutes, we'll open one up, step by step, and watch air, fuel, heat, and metal motion turn into usable power. Think of it as a guided tour through a working machine, from first breath to exhaust. A diesel engine is an internal combustion engine that burns diesel fuel to produce torque at the crankshaft. It's widely used in trucks, buses, ships, construction equipment, generators, and many modern cars because it's efficient and strong under load. Diesels typically deliver high low RPM pulling power and long service life. Compared with gasoline engines, the big difference is ignition. Gasoline engines mix air and fuel, then use a spark plug to ignite it. Diesel engines draw in mostly air, compress it much harder, and then inject fuel into that hot air so it ignites on its own. That higher compression helps efficiency, but demands stronger parts. Let's meet the main components. The cylinder block holds the cylinders. Inside, the piston slides up and down, linked by a connecting rod to the crankshaft, which turns motion into rotation. On top, the cylinder head contains the intake and exhaust valves, driven by the camshaft, controlling when air enters and gases leave. Air and fuel systems add the rest. An air filter cleans incoming air. A turbocharger compresses it using exhaust energy, and an intercooler cools that air for density. Fuel is pressurized by a high-pressure pump and delivered through injectors. Cold starts use glow plugs to warm the combustion chamber. Supporting it all, oiling, cooling, and a flywheel to smooth rotation. Second is compression. Both valves close, and the piston rises, squeezing the air into a small space. Diesel engines use very high compression ratios, so pressure and temperature soar. By the time the piston nears the top, the trapped air is hot enough to ignite fuel. No spark required, just physics and compression heating. Third is the power stroke. Right near top dead center, the injector sprays a fine mist of diesel fuel into the hot compressed air. The droplets ignite automatically, creating rapidly expanding gases that push the piston down. That force transfers through the connecting rod to the crankshaft, producing torque you can actually use. Fourth is exhaust. The exhaust valve opens, the piston travels upward, and spent gases are pushed out into the exhaust manifold. Valve timing is coordinated by the camshaft so intake and exhaust events happen precisely. As the crankshaft completes 2 full rotations, 1 complete diesel cycle is finished, ready to inhale fresh air again. Compression ignition is the diesel signature. Because the air alone is compressed so hard, temperatures can exceed the auto-ignition point of diesel fuel. There's no need for spark plugs during normal operation. Instead, timing depends on injection, swirl, and pressure. Glow plugs only assist when metal is cold and heat is being absorbed during startup. To make that injection possible, the fuel system starts at the tank, passes through a fuel filter, and reaches a high-pressure pump. Modern engines often use a common rail, a shared high-pressure manifold feeding each injector. Pressures can exceed 2,000 bar, and electronic control can trigger multiple small injections to reduce noise and emissions. Turbocharging recovers energy from exhaust. Hot exhaust gases spin a turbine wheel, which drives a compressor that packs more air into the engine. That compressed air heats up so it passes through the intercooler to cool and densify it. More oxygen allows more fuel to burn cleanly, increasing power, torque, and often efficiency. Inside the cylinder, combustion is a fast, complex mixing event. Injected diesel atomizes into tiny droplets, evaporates, and blends with swirling hot air. Ignition begins in multiple spots, then the flame spreads through the mixture. Expanding gases drive the piston down, and the crankshaft converts that linear push into smooth rotational power. All that heat and motion must be managed. Coolant circulates through jackets in the block and head, carrying heat to a radiator. Meanwhile, oil is pumped through galleries to bearings, piston skirts, the crankshaft, and the camshaft, forming a thin protective film that reduces friction and wear. Without cooling and lubrication, a diesel would fail quickly. Diesel emissions control adds another layer. EGR routes some exhaust back into the intake to lower combustion temperatures and reduce NOx. A diesel oxidation catalyst helps clean hydrocarbons and carbon monoxide. A DPF traps soot and periodically burns it off. Finally, SCR injects AdBlue to convert remaining NOx into nitrogen and water.